Okay. All right. So do you have your calculator and a sheet ready?
Yeah.
Okay. All right, nice. Let's see. Simultaneous equations. Okay. All right. Okay, so first things first. Do you have an idea of how to solve simultaneous equations?
No, not really.
Okay. Okay, let me see. Okay, now I can't annotate, but let me see if I can launch my whiteboard. Okay, so what we have basically simultaneous equations. The concept is that both of them are true at the same time. So the whole idea is one set of values for both x and y should satisfy both equations. So let me see. I'm trying to launch my whiteboard, but
I should stop screen sharing.
no. Don't worry. Let me see if I can start it. Okay. I'm supposed to be able to annotate, but I'm not sure. Okay. Do you have access to a whiteboard there? Do you
Why?
have an option there for whiteboard? Yes, do you?
Like writing on it.
Okay, you know what we'll do? Yes. Okay, but then I need to do the right thing. Don't worry. Let's do this. Let's do this. Let me see if I can do it in the chat. Okay, then I'll explain it to you. You can copy and you have a note-taking application on your phone, right?
As in where?
Maybe like an app on your phone for taking notes. Do you have stuff like that?
I should.
Okay, don't worry. I'm going to do it. I'll do it in the chat. Then I'll send it to you. Then I'll explain it as I'm going. But I would have loved you to, like see what I'm doing. Okay, so you know what we'll do? You read out the question for me. Then maybe I should just let me see if I can find the note sharing app on my phone. That should work. Okay. So the question we have before us is 5x plus 2y equals 27. Okay.
Yes.
5x plus 2y equals 27. Okay. And then, so I'm going to call that equation 1. Okay. And then the next one is the next one is 6x plus 4y equals 28. What did I do? 5x plus 2y equals equals 27. Okay, that's equation 1. Could you read out the second one for me?
6x plus 4y equals 28.
X plus 4y
equals 28.
equals 28. Okay, so that would be equation 2. Okay, so this is what we're going to do. Now, there are different methods for solving simultaneous equations. All right. The two methods notably that you could say stand out are the substitution method, and then the second one is called the elimination method. So I usually favor the elimination method. So I'm going to see if I can do a blend of both methods. So the whole idea again is that there is a value of x such that when you put it into equation 1, and when you put in the value of y into equation 1, it would solve it. In other words, when you multiply 5 by x and add it to 2 times y, it would give you exactly 27. Similarly, the same values for x, if you multiply it by 6 and you multiply the value of y by 4, you would get 28. In other words, the same pair of values for x and y would solve both equations. That's the whole idea of saying that they're simultaneous. So this is what we're going to do. Now, I always like to look for ways to make my work easier. So the first thing I'm going to do is I'll take a look at these two equations and see if there's anyone I can break down. Now, if you look at these two equations, do you think there's anyone we can break down in terms of division?
Sorry, as in
Okay, I said, do you think there's any of them that we can break down in terms of division? Like there's, you can divide through all the. Now look at equation 1. You have 5x, you have 2y, you have 27. These numbers are, I don't want to say that they're random, but if you look at them very well, you will see that we can't really help it because 27 is a multiple of 3. 2 can't go into 27 without a remainder, and 5 is an odd number that doesn't even play well with 2 or with 27. So equation 1 is out of the picture. But let us take a look at equation 2. What do you see in equation 2?
if you do 4 divided by 28, you get 7.
Yes. So now careful. If you divide, you can say you can divide through by 4, but the problem is 6 is standing in the way. So instead of dividing, did you get that?
6 is standing in the way.
Yes, because 6, if you say 6 divided by 4, there would be a remainder, isn't it?
Yes.
Okay, that's why I said it's standing in the way. That's what I meant. But let's try dividing by 2 and let's see what happens. Now, so equation 2 will look something like this. If you divide 6x by 2, you will have 3x, isn't it?
Yes.
And then divide 4y by 2, you will have 2y.
Yes.
And then divide 28 by 2 and you will have 14, isn't it?
Yes.
Good. Guess what we just did? We just created a third equation, but it's not really a new equation because it was gotten from equation 2. So you know what we are going to do? We are going to solve this pair of simultaneous equations using equation 1 and equation 3. Don't worry, I'm going to send you, I'll send you the chart as soon as I'm done. Okay, so maybe I should just send you the one I've done so far so that you can take a look at it. Okay, now, so you can see the equation 1, equation 2. Can you see my chart?
On your screen.
No. I sent it to you.
What did you send it?
The chat box on
Oh,
Zoom. Okay, so you have to stop sharing, right?
yeah.
Okay. All right, so can you see it now? Okay, so could I go on now?
Yes, yeah.
Okay, good. So remember, we're solving the simultaneous equations using equation 1 and equation 3. And remember that equation 3 came out from equation 2. Okay, so this is what we're going to do. This is what I like about simultaneous equations. Once you can find what do you call it? Once you can find something that's similar in both equations, you are good to go. So look at what we have in equation 1. Equation 1 is 5x plus 2y equals 27. And equation 3 is what?
3x plus 2y equals 15.
Yes. Now, what do you think? What can you see any similarities there? The coefficient of y is 2 in both of the equations. Did you notice that?
Yeah.
Okay, so this is what we're going to do. We're going to eliminate y. So that's what I'm going to do now. I'm going to eliminate y. So this how is going to look. And how will I eliminate y? I'm going to subtract equation 3 from equation 1. Okay, don't worry, you'll see how it looks. Let me just do the step. That means I'm going to have 5x minus 3x. So 5x minus 3x is what?
2x.
Good, 2x. Then, of course, you know what will happen when you say 2y minus 2y, isn't it?
Yes.
It's out. It's out of the picture. That's the whole essence. So you can, if you are free to say that I'm using elimination method, you can guess what I'm eliminating. I'm eliminating y so that I can find x. And when I'm done finding x, I can now go back and find y. That's the cool thing about elimination method. Okay, finally, 27 minus 14 will give me what?
13.
Yes, 13. Thank you. So this is what I have. 2x equals 13. So that means x will be equal to 13 divided by 2, right?
Yes.
And that's going to give us what? 6.5, isn't it?
Yes.
Okay. Now, I know you are thinking, if we have to substitute 6.5 into the equation, will it still? Yeah, that's the whole essence. I mean, this is a paper 2 exam, so that means you are free to use your calculator. But guess what? A calculator could slow you down a bit. So this is what I'm going to do. I'll still do it without calculator. So I already know that x is 13 over 2 or 6.5. So I'm now going to take that value for x, and I'll put it into any of the equations that I want, either equation 1 or equation what? Equation 3. Remember, we're working with two equations, right? Either equation 1 or equation 3. So which one would you like us to put it into? Let's put it into, let's see, 6.5, and which one works well with 6.5? Okay, so let's put it into equation 1. Equation 1 is 5x plus 2y. So this is what we're going to have. So this is what I have so far. Okay, I hope, were you following up to this point? I've sent you a message, a chat. Can you take a look at it? Okay, so you followed up to this point, right? Okay, so I'm going to remember the process of elimination is what? Eliminate one set of variables, or one set of one variable rather, find the other one. Then when you found the other one, use that one that you found and find the one that you eliminated. So now I'm on my way to find y. Okay, so this is what I'm going to do. Like I said, choose any of the equations and substitute x in it. So I'm going to choose the first one, which is 5x plus 2y equals 27. So this case, I'm going to have 5 times 6.5 plus 2y. And that would be equals 27. Okay. Now, if I multiply 5 by 6.5, what would I get? 5 times 6.5. That will give me 5 times 5 is 25. So remember how we multiply numbers that have decimal points, right? We multiply them as if there's no decimal point first. Then we now come and count how many decimal points there are and put the decimal point back, isn't it?
Yes.
Okay, so 5 times 5 is 25. 5 times 6 is 30. 30 plus 2 is 300, makes it 325. So that will now leave me with 32.5. So what do I do next? 32.5 plus 2y. Don't worry, I'm going to share the steps with you as soon as I'm done. 32.5 plus 2y equals 27. And then I'll now have to move 32.5 to the other side. That will leave me with 2y. So I think I'll need your calculator now. Can you subtract 27 minus 32.5? Or maybe we should, yeah. So maybe we should do it the other way. Let me see. Yes, what did you get?
I got minus 5.5.
Minus 5.5, right?
Yes.
Okay, thank you very much. Minus 5.5. So that means I have that 2y equals minus 5.5. And that means y will be equal to, you divide both sides by 2, and you have minus 5.5 divided by 2 over 2. And that's going to give me, what would you have? 5.5 divided by 2 will give you what?
2.75.
2 point what?
75.
2.75. Don't forget it's minus negative 2.75. So that's it. So I just sent you the last set of steps. Take a look at it. Let's see if it makes sense. Do you understand it?
Yeah, I'm reading it right now.
Okay, okay. All right.
Okay. Um, I should share my screen again.
Okay. Does it make sense? Did you understand the steps?
Yeah.
Okay. So I think the basic thing you can take away from this simultaneous this method I used is the fact that it's elimination method. Okay. And we are basically eliminating y because we saw something. Okay, what was it that we saw? We saw that the coefficient of y at a point was the same. That was the basis on which we were able to eliminate y, but it was not so at the beginning. um, we had to make it so by dividing equation 2 all through by 2. That was what made that 4 become 2y, and the rest of them also aligned. Okay, so the basic thing is to understand that elimination method involves eliminating one variable in favor of the other, and then as soon as you found the other one, then go ahead and substitute it in any of the equations. Any of them would do, and then find the second one that was eliminated. Okay, so any questions?
Yeah.
Okay, so how do you want to take this note? Would you copy the chat and paste it in your note taking application, or would you like me to send it to you via WhatsApp?
No, I've written it down. I've written it down.
Oh, okay, you've written it down. Okay, that's good. Okay, that's fine. All right, cool. Okay, so let's proceed then. Okay. Okay, so I think you would continue, right? I'm trying to
Yes.
exit my but okay. Okay. Okay, it says in Spain, Sam pays what? 27 euros for 18 liters of petrol. In Wales, Leo pays 40 pounds, 40 pounds and 80 pence for 8 gallons of the same type of petrol. Okay, so what's the question? 1 euro is 0.85 pounds, and 4.5 liters of petrol is equal to 1 gallon. Okay, so Sam thinks that petrol is cheaper in Spain than in Wales. This is a tricky question. It says, is Sam correct? You must show how you get your answer. Okay, so what do you think about this question? How do you think we should go about it?
Because we already have what they equal to, we would just divide Leo's amount by the amount that he equals to euros.
Okay, okay, okay. Would that be the first? Would that be your first line of action? Would that be the first thing you would do?
Oh,
so what came to my mind. Yeah, we could convert either euros to pounds or pounds to euros. I think one would be more convenient to do than the other. Which one do you think would be more convenient?
The euros to pounds.
Euros to pounds, because you have the value for 1 euro, isn't it? So all you need to do is to multiply, for instance, 27 by 0.85, isn't it?
Yeah.
Okay, so let's crunch that. So go ahead and do that. So you can write down the steps. The first thing we're going to do is we're going to change Sam's euros to pounds. So that's 27 times 0.85. What did you get? You can use your calculator.
£22.95.
22 pounds 95. So that's 22.95. Okay, good. All right. So now we have Sam's 27 euros in pounds. The next thing we're going to do is which one is easier for us to do? Liters to gallon or gallon to liters? I think if we follow the same thing, I think it will be easier to do gallon to liters, right?
Yes.
Yes. So let's change Leo's 8 gallons to liters by multiplying 8 by 4.5. What would you get? 4.5 times 8. What did you get?
36.
36. Was it exactly 36?
Yes.
Okay, good, excellent. So now 8 gallons is 36 liters. So what are we going to do next? Now we have everyone on level playing ground. Sam, let me see. Sam is having 22 point, did you say 0.95?
Yes.
Okay, 22.95 for 18 liters. And what's his name? Leo is having 40.8 for 36 liters, right?
Yes.
You know what we're going to do? For each of them, we're going to divide the amount of money by the number of liters. Okay, so for the first one, you're going to have 22.95 divided by 18. That's for Sam. Okay, so you can do that. And then for Leo, we're going to have 40.8 divided by 36. And then we'll compare both values and see which one is actually smaller. Should I take it again?
40 divided, the second one is...
Okay, just hold on, let me say it again. For Sam, I'm going to say 22.95 divided by 18. That's for Sam. Have you taken of that?
Hello?
Okay, all right. Can I go on to Leo now?
Yes.
Okay, for Leo, you have 40.8 divided by 36 liters. 40.8 divided by 36 liters. That's for Leo.
Sam equals 1.28 and Leo equals
1 point what?
1.28.
Okay, and Leo's one is what?
1.13.
Oh, so 1.28 and 1.13. Which one is bigger? That's 1.28, isn't it?
Yes.
So I guess Sam is not correct, isn't it?
Yeah, no.
Yes, petrol is actually slightly more expensive per liter in Spain than in Wales. Okay, so there you have your answer, right?
Yes, yes. Oh, wait.
Okay.
Let me get it. Sorry.
Okay. All right. Are you having a challenge there?
No, I have it.
Okay.
Yes, it says no, the petrol is cheaper in Wales.
Okay. Are you taking a look at the marking scheme?
Wait, that's not what you wanted.
Okay, no, I was just saying, if you were writing down the answer, I thought you were writing down how to solve it, your steps.
Oh no.
Okay, all right. Okay, don't worry. If we need the market scheme, I'll let you know. I think we can, so that it will kind of make us faster if we don't have to always be referring to the marking scheme. Okay, so I think we can move beyond this, right?
Oh yes.
Okay. Okay. Okay, this one should be pretty easy. It says a new phone costs £679. The value of the phone decreases at a rate of 4% per year. Work out the value of the phone at the end of 3 years. Okay, so how would you take on this guy? The phone decreases at the rate of 4% per year. Do you think it's going to add up to 12% at the end of 3 years?
If it's decreasing.
No, it's decreasing, right?
Yes.
Okay. So do you think it's going to, I'm just looking at it because it says the value of the phone decreases at a rate of 4% per year. So how would you take on this? I'm just thinking, if you have to do 4% per year, right?
Yeah.
That means you are going to take 4% of £679. You get your answer. That's for the first year, isn't it?
Yes.
Okay. So this is the whole idea. Value is decreasing. That means we're going to be subtracting at some point. So we're going to say 4% of 679. Okay, that's 4 over 100 times 679 over 1. We'll get the answer for that. Then subtract it from 679, right?
Yes.
And then what next? That will give us the value for the second year. Okay, and then we'll do the same thing, but this time it's going to be 4% of the value. So let me see if I can, let me send you what I'm trying to explain in the chat, so you can take a look at it. Don't worry, just keep it open. When I send it the chat, then maybe you can stop sharing. So it's 679, right, times 4%. 4% is 0.04. So that will make it easier for us to calculate. So can you give me the answer for 4% of 679 on your calculator? That's 0.04 times 679. What do you have?
$27.16.
27.16.
16.
Okay. Now subtract that from 679. What do you have? 679 minus 27.16. What would that give you?
Sorry. No.
679 minus 27.16.
651.84.
651.84. 0.84.
Yes.
Okay, good. All right. Now, 651.84. Remember, it's the same. What do you call it? 4% now. So this was for the first year. Let me. So I'm going to tag it year 1. This is after year 1. So we're now going on to year 2. This time we're going to be saying 651.84 times 0.04, since because it's the same percentage, it says every year. So 651.84 times 0.04, what would that give you?
Order.
651.84 times 0.04, what would that give you?
26.073.
26.0 what?
073.
Okay, so can we just take it to 2 decimal places so that we don't have to have too many decimal places at the end of the day?
26.73.
0.73. Okay. All right. Okay. Then let's subtract this 26.73 from 651.84. 651.84 minus 26.73. What would that give us?
$625.11.
What did you say? 625?
0.11.
625.11. Okay. All right. Then finally, year 3. Year 3 is going to be 625.11. Sorry, I went at that 525. 625.11 times 0.04 again. What would that give you?
25.44.
25.44. Okay. Finally, let's subtract 25.44 from 625.1.
65.1.
65. 625.11 minus 25.44.
599.66.
500 and what?
99.66.
Okay, excellent. So that's the value after 3 years. Let me share what I did with you so that you can see it. Okay. So go ahead and take a look at the chart.
Yeah, I'm seeing.
Okay, you see it.
Yep.
Okay. So do you understand the steps I took?
Yes, I do.
Okay. So the important thing to remember is that the value was decreasing. So each time you multiplied it by 4%, you multiplied the new value by 4% each time. And then you subtracted it from that new value to get the value for the next year. Okay, so we're moving on now. Do you want to write it down?
Yeah, no, I have it. I was writing it as you were speaking.
Okay, all right, good. Okay, all right, so this one is about shapes or lines. Okay, LMN as such that LMN is a straight line. Okay, coordinates. -3, 1, 4, 9, giving that. This one looks like it's going to need a sketch. It looks like it's going to need a sketch.
Yeah, I think it does. It needs a sketch.
I'm not sure I don't have my white. I can't share. Maybe if I had been using I wish I could share my this thing, but I can't. Share. Okay, I think we'll just pass this one.
Pardon?
Or would you be able to do the sketch?
I think I can.
Okay, so this is what we're going to do. Okay, fine. Okay, fine. It's okay. Okay, let's see. But then now you don't really have a ruler, do you?
Yeah.
Okay, you can use a ruler there. Okay, fine. Okay, fine. Okay, let's see. Let's give it a try. Let's give it a try. Let's see if we can attempt to do this question. Okay, so it says the coordinates of L are -3, 1. So -3, 1 means that what does it mean? It means that the x-coordinates of L, the x-coordinate of L is -3, and the y-coordinate of L is 1. Okay. Okay. Is that the shape you are trying to draw?
Yeah.
You mind explaining what you are doing? Let me see if it's in line with what's in my mind.
Now, during the two angles, like
Okay. Okay. Okay, that's minus 3. 1. Okay. Okay, so n is at the other end, right?
Yes.
Okay. Right. So the question now is, what are the coordinates of n?
If one part is
You know what? I think let's skip this question. This question would have been really fun. Number one, if we had the graph sheet, it would have been perfect. Though a ruler would have done something similar, but I can't really place things well when it's plain like this. A graph sheet would have done a very good job. I hope they would share a graph sheet at the exam for questions like this, because that would be the best.
wait, what sheet?
You know those those graph papers, those ones that have those small squares.
Oh, okay.
Yes, yes. Okay. Okay, this one is a word problem. It says Festival A will be in a rectangular field with an area of 80,000 square meters. The greatest number of people allowed to attend Festival A is 425. Okay. It says Festival B will be in a rectangular field to 700 meters by 2,000 meters. The greatest number of people allowed to attend Festival B is 6,750 people. Okay. The area per person allowed for Festival B is greater than the area per person allowed for Festival A. The question is, how much greater? Give your answer correct to the nearest whole number. Okay, so how would you do this question?
I have to find the area per person.
The area of which one? Festival B?
Yeah.
Okay, good. So that's the first thing we're going to do. We'll multiply 2,000 by 700. That's going to be what? 100. Sorry, what's that going to be? 7 times 2 is 14. What would that be?
Pardon?
If you multiply 700 by 2,000, what would you get?
1,400,000.
Okay, 1,400,000. Good. Okay, now what are you going to do next? You're going to divide 1,400,000 by 6,750, isn't it?
Yes.
Okay, what would you get?
207.4.
207.4. Okay. All right. So let's keep that for Festival B. Now divide 80,000 by 425. What did you get? That's for Festival A.
188.2.
188.2. So, of course, they've already established that Festival B is greater than, in terms of area per person, than Festival A. So we already know that. The question is how much greater? You simply subtract the smaller one, that's the one for A, from the one for B, isn't it?
Yes.
And then remember to give your answer to the nearest whole number. What would you get?
19.
19.
Yes.
Okay. All right. Okay. It looks like this question has more than one question in it. What's the second one? Okay. 300 cm squared is the same as 3 meters squared. Because there are 100 centimeters in 1 meter. Okay. Callum's method is wrong. Reply why. Well, so what do you think about this question? It looks funny, but well, I want to know what you think about it. Okay. So let me see if I can just explain it. Now, under your units, right? You have the 100 centimeters is equivalent to 1 meter. That's correct, isn't it?
Yes.
Good. Now, when you want to now find the area measure, now imagine area measure is in squares, isn't it? So imagine that in each 1 meter, you have 100 centimeters. So if you are going to say, find out what is in 1 meter squared, don't you think that's going to be what is in 1 meter times what is in 1 meter? Is that not what a meter squared would amount to?
Yes.
Good. So that would have been 100 times what? 100. Did you get that?
Yeah. Yes.
Now, what Callum is saying is very, very faulty because 300, 100 times 100 is going to give us, what's 100 times 100? 30,000, right?
3,000.
If you, it was 10,000, sorry, 10,000. That is for 1 squared meter. Now, 3 squared meters is definitely going to be 30,000, isn't it? Does it not make sense?
Yes.
Look at it that way. So, Callum, his estimation is wrong based on what we just deduced. Okay, so your starting point is to start back up and start from the fact that 1 meter is equal to 100 centimeters. Okay, then now establish what 1 squared meter would be. And 1 squared meter is a result of 1 meter times 1 meter. That is 100 centimeters times 100 centimeters. That is 10,000 centimeters squared, right?
Yes.
Then we can now go on to find out what 3 squared meters would be, which is simply going to be 3 times 10,000 centimeters squared. That is 30,000 centimeters squared. So that would make Callum's method wrong. Okay. Okay. Oh, this question looks. The length of a football pitch is 90 meters, correct to the nearest meter. And it says complete the error interval for the length of the football pitch. Error interval. Ooh. Okay, I'm not too sure of this. Could you check the marking scheme for this one? I'm not too sure of this error interval. I know there's a certain error percentage somewhere.
Is the first one 89.5?
Okay, the first value.
Yeah, because it's saying it's equal to 90, because 90 is the length.
Hmm. So that's the thing, yeah, so it could be 89.5, it could be 89.05, it depends. What would be the actual figure? I'm not too sure of it. I'm not too sure of it. To the nearest meter.
Yeah, it says
Okay. So okay, what does it say? What does the marking scheme say?
yeah, so yeah, 98. Yeah, so the first one is 89.5 and then the second one is 90.5.
Okay, 89.5 and 90.5. Okay. All right. Okay, that's fine. All right, let's see. Let's move on to the next one. This one looks more like it. Can you see? I think this graph does a better job at representing information better. Okay, what does it say? Transformation of map of shape S onto shape T. Are you good with transformations?
Is this a translation?
Yes, it's more like it. So I'm just looking at it. S and T actually look similar, right? It's just where their location is kind of different. So let me see. If I do a it says describe fully the single transformation that maps shape S onto shape T. So if I do that, let's see. If we flip S from that right hand side where it is onto the left hand side. Okay, no, that will not be.
I think I
Let me
can.
see. What did you say?
I think I know how to do this one, so I can just. It's just lines, so I can draw it. I know how to.
Okay, just
Yeah, so.
okay.
So right there. So
Okay.
2, 3, 4, 5. Okay, minus
5. Okay, minus 5. Okay.
6 and 6.
Minus 5 and 6. Okay, that's for that point. Okay.
Yeah.
Are you able to translate all the other points too? Or that should be enough for it, right?
Yeah, because it's just a translation to me.
Okay. All right. Okay, that's fine. Okay. Okay. So what does this question say? Simplify. Okay, I guess you can do these ones, right? So go ahead and attempt that one. That first one is simply you have to multiply the power of x inside. The power, which in this case is 3, you have to multiply it by 5. So that first one is going to be x raised to power 15.
Yes. Yeah.
Okay. All right. So that one is basically from the laws of indices. You get that. So now the second one is the one that's a bit tricky. Can you do that second one? You're simply expanding. Yes, give it a try. Let's see. So you'll be multiplying 4 by x and then 4 by 3. And then, of course, 7 by 4 and 7 by minus 2x. So what would you have?
4x plus 12.
Yes. Plus
20
28
minus 14x.
minus 14x. Good. So let's collect the like terms. 4x minus 14x would give us what?
10x.
Minus, don't forget, it's a minus 10x because, yes, minus 10x. So if we rearrange everything, it's going to be 12 plus 28. So 12 plus 28 will give us what?
30.
That's is that 40?
40.
40, okay. So the final answer would be 40 minus 10x, right?
Yes.
Okay.
Wait, minus
So, yes.
10.
Yes, minus 10x.
Okay.
Yes. Okay. So let's move on. Factorize fully. Okay, so this third one looks like it's we're going to be looking for the common factors. So what do you see in common between 15x cubed and 3x squared y? In terms of the numbers, let's start with the numbers 3 and 15. What is the common factor?
5.
We can't do 5. The reason being that 3 is the lowest in this scenario. So I think we'll need to use something that is common to both of them. So 5 is okay with 15, but 5 is not good with 3. So let's use 3, since 3 is good with itself and good with 15. Okay, so if you take out 3, you'll be left with 3 on the outside. Since it's a factorized question, it's going to look like this. 3 outside the bracket. Let me send it.
There's nobody in the world that does work and pays for transport for work.
Cubed plus 3 y. Let me send it as a chat.
What is he talking about? Is it my
X cubed. Okay. plus 3x squared y. Okay, we're simplifying. Well, sorry, we're factorizing. So we said 3 is common. So you put 3 outside the bracket. Then the next thing that's common between them, a lowest factor. If you look very well, you can see x squared on 3x squared y. And you can also see x squared in 15x cubed. Okay, so we're going to take x squared out as a common factor too, so that you have outside, you will have 3x squared. And then if you divide 15 by 3, you would have 5. If you divide x cubed by x squared, you'll be left with x. And then you will now be left with y, because 3x squared y. By the time you take out 3x squared there, you would be left with only y. Okay, so take a look at this. I sent you something in the chat. Can you see it?
Yes.
Okay. Okay. Does it look familiar?
Yeah, yes, it is.
Okay, cool. All right. Okay. Do you have any questions or you want? Can we continue?
And then we can continue. That's all.
So, okay, this is a probability tree diagram. Now, let me just tell you the secret to this, completing this diagram, right?
Yes.
Remember when we said something about total probability? That probability is usually a fraction, right? And it's less than 1. So total probability would always amount to 1. So the probability of something happening is, say, A. The probability of that thing not happening is 1 minus A. Okay? So that's the secret to this guy. So for instance, they said Lorena gets a train. Okay, so the first probability that we're measuring is that she will get, the probability of her getting late to work is 0.13, according to this diagram, right? So what's the probability that she will not be late? Simple, 1 minus 0.13. Okay, so can you do that on your calculator? Let's see what you get. 1 minus 0.13. I think it's going to be 0.87, I think.
Yes. Yeah, 0.87.
Okay, next one. Probability that, another probability that she's taking a train home, that she will get home late is 0.06. Probability that she will not get home late would be 1 minus 0.06. So that would be 0.94, right?
Yes.
Okay, so that's basically what you're doing. You're just simply subtracting each one from 1. Okay, it must for each section of the diagram, it must add to 1, it must add up to give you 1. Okay. Okay, so you can still confirm with the marking scheme, maybe later when you are going
Yeah, okay. So I should move.
Okay. Okay, so this one is talking about, I think it's still probability. It's not probability. Okay, profit. Nimra buys a 3 kilogram box of sweets for £17.60. She puts the sweets into bags to sell. And each bag contains 150 grams of sweets. Okay. Okay. All right. It says Nimra fills as many bags as possible. She will sell each bag for the same price. And she wants to make a profit of at least 35%. Wow. Okay. Assuming she sells all the bags, what's the lowest price Nimra should charge for each bag? Okay. Okay. So this question looks a bit tricky, but if you wanted to solve it, I think the best thing to do would be to find out what, in terms of cost price and selling price, what would that come to for one bag? Okay. So let's see. Let's start with the beginning of the question. It says she buys a 3 kilogram box of sweets. Now, the question is this. Each bag contains 150 grams of sweets. In other words, one bag is 150 grams. So how many 150 grams can we find in 3 kilograms? Okay. Because they said she puts all the sweets. She fills as many bags as possible. So how many 150 grams can we find in 3 kilograms? Now, you know what we'll do. Can you use your calculator to find out how many 150 you would find in 3 kilograms? In other words, remember 3 kilograms is 3,000 grams, right?
Oh, yes.
So divide 3,000 by 150. What would you get?
20.
20. Exactly 20, right?
Yes.
Good. So, in other words, she came out with 20 bags of sweets to sell. Now, remember, the cost price is 17.60. So, for us to find, let me say, let's find the cost price for one bag. So we're going to divide 1760 by 20. Let's convert it to should we convert it? Let's convert it to just pence. 1760 divided by 20. What would you have?
$0.88.
0.88, right?
Yes.
Okay, good. Okay, so that means that's still in pounds. Okay, that's cool. Now, you see that 0.88. That 0.88 is the cost price. For you to make a profit, for Nimra rather, to make a profit of at least 35%, guess what? That's going to mean an increase in the price. for her to make a profit on each bag. So what we're going to do now is we're going to, instead of doing it the long way of multiplying 35% first by 0.88, then adding it back to 0.88, let's simply say 100 plus 35, okay? 100 plus 35, that's 135% of 0.88. So can you do that on your calculator? Let's see what it's going to amount to. 135 divided by 100, that's 1.35 times 0.88.
1.188. 1.188.
Okay, 1.188. That's approximately 1.19, isn't it?
Yes.
Okay, so that is the amount that she would need to sell each bag if she has to make a profit of at least 35%. That's the lowest price she will have to sell each bag. Okay, of course, lowest price means that she can sell it at a higher price if she wants. And that's the whole idea of saying at least 35%. So she could have sold it at something higher, maybe £2 or something. But for the lowest that she can sell it, that's going to be £1.19. That's £1.19. So did you get the flow of my calculation?
1.19.
Yes.
Yes.
Okay, so you remember where we started, right?
Yes.
Okay. First things first, try to establish how many bags she could get out of that 3-kilogram box. So that was the first thing we did. And we did that by dividing 3,000 grams by the number of grams for each bag. That was how we started.
Yes.
Okay. Okay. Any questions on this?
No.
Okay, let's see. Okay, what do you think about this one? You remember what we said about mean, right?
The mean.
Yes.
The average.
The average, yes. $115 appointments were missed last month. These missed appointments were a total of 25.3 hours. And then it says, work out the mean length of time for each missed appointment. So basically, you're dividing 25.3 hours by 115, right?
Yes.
Okay, but then I think the best thing would be to convert 25.3 hours to minutes first. So what would you do how would you do that? We'll multiply by 60, isn't it?
Multiply by 6.
By 60.
Oh, okay.
Yes, 60 minutes make an hour, right?
Yes.
Okay. So if you multiply 25.3 by 60, what would you get?
Um, 1,518.
Okay, 1,518. Okay, now divide 1,518 by 115. What do you have?
13.2.
Okay. 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 So that's the answer. And they didn't say we should make it a whole number, right?
No,
I
it
think
just
we
said
can leave it as
give it a minute. That's all it says.
okay. All right. Okay. Okay. In a bed shop. During the last 3 months, she sold 198 beds. Okay. 9 without a mattress. 45 were double beds. 16 of the single beds were sold without a mattress. But this is just data. 67 of 83 king size beds were sold with a mattress. Use this information to complete the two-way table. Is this something you can do on your own?
Yes.
Based on the
Yes.
Okay, so it's not tricky, right? It's something you can quickly do.
Yeah.
Okay. Okay. You see, here is the number machine. How does this say next? Inputs is that plus 7. Okay, plus 7. Plus 7 leads to plus 5. And then what happens? The output is what? Oh, okay, I get it. So input divided by 7, and then after that you add 5 to it, okay? Gives you the output. It says, work out the output when the input is 28. This is quite straightforward, right?
Yes.
Okay, so what would be the answer?
I'm 9.
Are you sure about that? Okay, let's see. 28 divided by 7, that's 4. Okay, yes, correct. Yes, it's 9. Okay, let's move on. Here's a different number machine. And they don't tell us what the first one is. But it's addition. And second one is multiplication. It says when the input is 8, the output is 154. Complete the number machine. Can you figure this one out? What's the first thing we're going to do?
Do the opposite.
Okay, so we would divide by 11 first, right?
Yes.
We would divide 154 by 11. What would that give you?
14.
14, okay. So I have 14. So what would we add to 8 to give us 14?
6.
That's 6. So 6 is going to be in that first box. since 8 is the input. You get it now?
Yes, yes.
Okay. All right. So this one is like, this one was quite easy. Okay. All right. Okay, so move on. Mm. Okay, what do you think about this one?
Well, firstly, because it's really giving me two of the, I mean, A and B. I just add it and subtract it from 180.
Yeah. Okay. Then what next?
Then whatever I get will be the angle, and then the opposite angle is equal to.
Yes. The third angle. But now notice, they want the other angle, not the one that's inside the triangle. They want the one that's outside the triangle. So what are you going to do to get that one that's outside the triangle? It's actually the same thing. You know why? There's a law. There's a law that says that vertically opposite angles are equal. Okay. So if you add 116 to 25 and you subtract your answer from 180, it will give you the angle inside that triangle. But guess what? That angle is vertically opposite to the one they want us to find. So indirectly, we have found the answer. We have found the angle x by just doing what you said, adding 116 to 25, and then subtracting your answer from 180. Did you get that now?
Yes.
Okay. So that's it for the for this triangle. So I think the only reason you need to give the two reasons are: number one, sum of angles in a triangle is 180 degrees, and then the second reason is that vertically opposite angles are equal. Vertically opposite angles are equal. Okay. This one is about Sonia. It says Sonia wants to book a holiday. The holiday will cost £1,428. Sonia will pay a deposit of £150. She will then pay the rest of the cost in 6 equal monthly payments. Okay. Okay. It says how much is each monthly payment. So the first thing would be to subtract her deposit, right?
Yes.
Okay. So 1,428 minus 150 will give you what?
$1,278.
1,278. Okay. So what are we going to do next?
Divided by 6.
Exactly. Divided by 6. Yes. To get what each monthly payment would be. Okay. So when you divide that by 6, what did you get?
213.
Exactly. All right. Okay. So I think we can move on. That's the answer. Okay. Oh, this one has to do with the graph. Oh, let's see. The graph shows information about the number of houses sold by an estate agent. In each of 6 months last year, number of houses sold, blah, blah, blah. Okay, all that. What does it say next? How many houses were sold by the estate agent in February? That would be, I want us to read this graph accurately. Number of houses sold. 20, 20, 30. So that's going to be 20. Is that 20, 22, 24? So that's going to be 23, right?
23.
Yes. Can you see why I'm reading it as 23? The X seems to be in between that box. It's not exactly on the box where that line crosses, and it's not exactly on the one above it. Can you see it?
Yes.
So do you agree it's 23?
23, yes.
Okay, all right. So that's for February. What next? It says for this estate agent, write down the ratio of the number of houses sold in January to the number of houses sold in June. Okay, January is quite straightforward. January is 10. June is what's that? June is 26. Sorry, not 26. 56.
Yeah.
So remember, ratio has an order. It says January to June. So 10 is to 56. If you were to do the ratio of 10 to 56 and you were to break it down, what would it be in its lowest terms? 5 is to 28.
5 to 28.
Yes, because if you use 2 into 10 is 5, isn't it? 2 into 20 into 56 is 28, isn't it?
Yes.
Okay.
All right.
Okay. Okay, this one is having to do with the polygon. So do you know the mathematical name for this guy? How many sides does he have? That's what will tell us the name.
6.
1, 2, 3, 4, 5, 6. So for I think a 6-sided polygon is called a hexagon, right?
Yes. Yes.
Okay. Then what next? It says which side of the polygon is parallel to the side CD. Obviously, that's AF, isn't it?
Oh, yes.
Okay. Moving on. It says write down a side of the polygon that's perpendicular to the side AF. Perpendicular just means it's at 90 degrees, right?
Oh, okay. Yeah.
Okay, are you familiar with the term perpendicular?
Like I don't know.
Yes. So anytime you have a line at 90 degrees to another line, okay, it's safe to say that both lines are perpendicular to each other. Okay. So in this case, if you look at this diagram very well, there are two lines that are perpendicular to AF. Number one, AB, and number two, FE or EF. Okay, can you see that? They are both at 90 degrees to AF. Okay, so we're assuming this is a graph sheet and that all these squares are squares, like squares in the true sense of it. So we are safe to understand, to assume that there's 90 degrees there where A and F are. Okay. All right. So I think, is that all for this question?
Yeah, that's done. That's fine.
Okay.
That's fine.
Okay. 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 So what does it say? Write a fraction in the box to make the calculation correct. Okay. So do you remember how we did something similar to this? 1 minus 3 over 10. Do you remember how we did it back then?
No.
You know, so the denominator is 10, right? If you have a 1 on the left-hand side, all you need to do is to just ask yourself, what would give us 1 in this scenario? A number divided by itself. So in this case, our denominator is 10. So if we say 10 divided by 10, right, what do you have? Is still 1. So you can write this as 10 divided by 10 minus 3 divided by 10. The 10 in the denominator is simply going to be the same, and you have 10 minus 3, which will give you 7. Okay, so that's going to give you 7 over 10.
Oh, okay.
Did you get?
So you turned the 1 into 10 over 10?
Yes, I turned the 1 into 10 divided by 10, just so that it would have the same denominator as the 3 over 10.
Okay.
Yeah. Okay. It says here is a list of numbers. Write down the mode. Okay, mode of a set of numbers is the one that has the highest frequency, right?
Yes.
And in this case, clearly it looks like 3 to me, right?
Yes, yes.
Okay. What's the next one? It says write down a 3-digit number that is a multiple of 5. A 3-digit number that's a multiple of 5. The one that comes to mind, there are 2 that come to mind though. 125, 625, 625, right? Are you familiar with those 2 numbers? They usually, you find them most calculations. 5 times 5 times what will give you 125 again? 5 times 25, and then 625 is what? Is 5 and 6 is 1, remember 1 and 12, 2. Okay, so 625 is 5 times 125. So both of them are 3-digit numbers that are multiples of 5. Okay.
Kind of.
So did you get what the question was all about?
Yeah.
Okay. All right. So we can move on, right?
Oh yes.
0.4 as a percentage is simply 0.4 times 100, nothing more. Multiplied by 100, the decimal point will move 2 places to the right, 1 time over 4, and then 1 time over the 0 behind 4. So that will leave you with 40%. Yeah. So this is, can you see, these are some of those kind of calculations I told you. You can do them without punching your calculator, without writing down anything. You can do them off the top of your head. Just get them done and get the answer out. Write it down and move on. It will make you really, really fast. Okay. Are these is this it for the questions? Were we able to go through all of them?
Yes.
Okay. Okay. Is that an alarm or something?
This is another people.
Oh, okay. Okay.
My friend sent to me, so
Okay.
I don't know why I explained it now. But yeah.
Okay. Hmm. Okay. It says sketch the graph of y equals 1 over x. I think this graph, let's see. When x is 1, y is 1. When x is 2, y is half. Okay. Okay. Zero point three. Okay, so let me see. The graph of this guy, it looks like it's going to be a curve, right? But there will be no value for 0. So it's going to be a curve that you would find on the lower left. It will go lower left, curve on the lower left quadrant, and then on the upper left quadrant. Okay. Now you can see that it would not go for 0, because if you put 0 in that denominator, guess what will happen? 1 over 0 will give you what? Have you ever tried that calculation before?
This
Yes.
to draw it. Yeah, I think I've done it before, I believe.
Okay. So it gave you a curve, right? Yes, something like that. Exactly. And then on the yes.
Oh,
Yes, that's it. Yes. Okay. Yes, that's it. Okay. Okay. It says the diagram shows a sector of a circle, center O, and radius what? 8 cm. All right. What does it say next? It says OPR is a triangle, obviously. Work out the area of the shaded segment PQR. PQR. Okay. Give your answer correct to 3 significant figures. Okay, so you know what's going to happen for this guy. You need to find the area of the sector, of the full sector. This looks like a quadrant of a circle, right?
yes.
So we'll find the area of that quadrant. Then we're going to subtract the area of the triangle, the right angle triangle, POR, from the area of that quadrant. That will give us that shaded part.
There's nothing else.
Which is, can you see how I arrived at my decision?
Did you write it?
Okay, no, I okay. So I was just saying, do you understand how I arrived at that decision? Why I had to say subtract the area of the triangle from the area of the quadrant.
Okay, so because it's 1/4, we're doing area of a circle, but divided by 4.
Yes, yes, that's for the that quadrant, right?
Mm-hmm.
Okay, then the for the triangle, its own area would be half base times height, isn't it?
Oh, yes, yes.
So its base, you can use any of those 8 as its base. So you can say half times 8 times 8. That's going to lead you to 4 times 8, 32. Okay, so I've helped you calculate the area of the triangle. You can go ahead and calculate the area of the quadrant. The area of the quadrant is going to simply be pi r squared divided by 4.
Okay. So, 16 pi centimeter squared.
Okay. 16 pi minus what?
32.
Are you positive about the 16 pi?
16 pi.
Oh, okay. 64 divided by 4. Okay, yes, you're correct. You're correct, yes. So that's 64 pi minus, 16 pi, you're right. 16 pi minus 32. Yes, you're right. Okay. Okay. So you can get the answer correct to 3 significant figures, right?
Oh, yes. 18.30. 18.3, sorry.
Okay, 15.3, good. Okay. All right, so we can move on. Let's see if we can quickly squeeze in one question before it's 8 o'clock. Okay. Oh, it's a probability question. In a bag, there are only red counters, blue counters, and green counters, and pink counters. Okay, interesting bag. A counter is going to be taken at random from the bag. It shows the probabilities of taking a red counter or a blue counter. The question says, the probability of taking a green counter is 0.2 more than the probability of taking a pink counter. It says you should complete the table. Now, you know what you're going to do. Remember, total probability would always be what?
It's 1 minus.
1, good. It's always going to be 1. So what that means is that I'm going to have 0.05. Let me see if I can send it to you as a chart. But you can be writing it down as I'm saying it. 0.05 plus 0.15. Let me take note of it. 0.05, 0.05 plus 0.15 plus. Now, you were told that the what? The probability of, can you read that part that it says the one for the pink one versus the one for the?
And the probability of taking a green counter is 0.2.
No, it's not just 0.2. It's 0.2 more than something.
Or more than the probability of taking a pink counter.
Okay, so that means that for a green counter, right? If
Yes.
the probability of taking a pink counter is X, then that means the probability of taking a green counter is 0.2 plus X. Do you agree with that?
Okay. Plus X.
Yes, it's plus. Did you notice that it's not times? The reason it's not times is that they didn't say 0.2 times. They said 0.2 more. Okay. So I think you need to put in questions. When they say more versus when they say times. Okay. So I'm going to send you what it's going to look like now. What the equation will look like.
Okay.
What was the first? Can you tell me what was the first color? I can't really see the screen as I'm typing. What's the first color?
Red.
Red. Okay. What's the second one?
Blue.
Blue. The third one I think is green, and then the fourth one is what? Pink.
Yes, pink.
All right. So take a look at what I sent to you in the chat box. I'm going to solve it now. So 0.05 plus 0.15 will give me 0.20 plus 0.2 plus 2x. All this equals 1. So that's 2x 2x will be equal to 1 minus 0.4. And that's going to be 2x is equal to 0.6. And finally, x is equal to 0.6 divided by 2, which is 0.3. Okay, so can you see what I just sent in the chat?
Yes.
Okay. So does it were you able to follow?
Yeah. I've been writing.
Okay. All right. Okay. So what's your key takeaway from this question? Understanding the terms when they say something is maybe a particular value more than another thing. When they say that kind of thing, just understand that it's addition. Okay. But when they say it is something times more than another thing, then know that it's what? Multiplication. Okay. And of course, the flip side also, the converse also applies. If they say something is, say, 0.2 less than would imply subtraction. Okay. But if they say it is 2 times less than something, then that would be what? Division. Okay.
Okay. Yeah.
Okay. So I think it will be safe for us to stop here for today. I am not too sure how about tomorrow, but I think we were able to do 2 days for this week. Let me see. Maybe your mom is going to send me your schedule for your exam so that we know how we could navigate. When are you starting? Would that be next week? Or you don't? Okay, you don't really remember the
Yeah, you have to look.
how your timetable looks like, right?
So let me just find it. So
Okay.
Is it the one I wrote? No, send the one I wrote. This one. Forward.
did you actually? Yes, I sent it to our chat.
Okay. All right. Okay, that's fine. Okay. Okay, that's fine. Okay, would you be chance to have a class on Saturday?
Oh yeah, I have zero. Sorry, I have my other teacher on Saturday.
Okay, you'll be busy on Saturday.
Yes.
Okay. All right. Okay, maybe just let me know what your what's the next schedule will be. Maybe so that I'll know
The week.
it's during the week, right?
Yes.
Okay.
Monday, Tuesday.
Okay. All right. During the week, I think Tuesday would work for me. Let me just see. Mondays, Wednesdays, Fridays. Tuesday is good with you?
Yes.
Okay.
6 to 8.
Okay. All right. Okay, no problem. Okay, so just all right. In case there are any questions you want us to still look at, maybe you could send me
Which other,
questions on that.
are you able to do Thursday?
So Tuesday and Thursday.
So Tuesday and Thursday. Next. Next week.
Twenty-ninth and first.
To 29th and 1st.
No, 29th and 1st of year, or 29th and 1st of May.
29th and 1st of May. Done. Okay, my mom will
Okay, I've seen them.
message you.
All right then. Okay, have a good night.
You too. Bye.